Welcome back to another episode of From the Field. I am your host, Casey Orr. I am an SA based in Wellington, and with me I have Navia, which is a solution architect based in Melbourne. So we got a bit of the old Anzac spirit going on again. Some of you might have noticed that there's a bit of a difference here. I am, for once in my lifetime, well lit, and I'm also wearing glasses. I wanted to make everyone feel inclusive there. But we just actually built a new studio in the Auckland office in New Zealand. So that is what I'm using now. We are still going through the teething issues. So if you do notice anything weird or you can hear me breathing or all of that stuff, just call out because as I said, there is definitely some teething issues. And if I am looking down, it's because, again, we don't have our monitor up. So we're working through all this, but don't worry, that is someone else's problem right now. We are going to be covering off continuous delivery with GitOps for EKS. Navia here is an expert on that as part of the container specialty at TFC internally. So I'm going to hand over to Navia to introduce yourself, go over the topics that we're going to be covering, and also go through what your demo is going to entail as well.
Sure. Thanks, Casey. I can hear you loud and clear, so it's all working well for now. Hi, everyone. I am Navya, AWS Solutions Architect. I'm here to go ahead and explain a little bit about continuous delivery, GitOps, and how it would work on EKS. There's a short demo and explanation on how one of these tools work, which is called Argo CD. So it's kind of a cool one because it's UI based, which is kind of rare when it comes to EKS and containers. So really excited to go ahead and explain all of that to you guys.
Have you experienced a few customers using Argo?
Yes. So a lot of customers have been going towards GitOps for sure with EKS. I do have a slide where we discuss what customers they are, pretty big ones. And then a lot of them who are startups and medium-sized companies, they want things to be leaner and more agile, which means they would want to go towards GitOps. And then obviously using these tools, it makes it very easier for them to do so as well.
Awesome. Well, enough from me. Why don't I bring up your slides that you have, and then we can take it from there.
Sure. All right. So let's start off with a little bit of introduction in regards to continuous delivery. So it actually should start with an explanation towards the release process and the stages involved, first of all, because every application deployment or infrastructure as code deployment should basically incorporate this part. And this has been done in the application and software industry for a long time. So as you can see on the screen, we are basically talking about these 4 stages of any application development. And now we incorporate something similar with infrastructure as code as well. We start off with the source, where we basically check in our code, go ahead and do peer reviews, and then push it through for us to go ahead and build the code itself, which means we'll compile it, go ahead and perform unit tests, lint checks, or basically style checkers as well. And then if we are using containers, we go ahead and package it as an image so that we can go ahead and deploy and test it in our feature environments or test or staging environments, which is basically the next part, which is the test. It's actually done for integration testing. What I mean by integration testing is to actually test your particular feature that you have deployed with other systems around in the whole application universe that you host. And then when all of this is done, we go ahead and do load testing, UI testing, very important high priority stuff, which is security testing as well. Once all of that is good to go, we go ahead and deploy this into production. So this is fairly common amongst all companies that we come across who create and deploy applications itself. Moving on, we talk about the release cycle itself. So as you can see, with these 4 stages, we have these different processes that we use. The first one would be continuous integration that goes up till test phase. And then we talk about continuous delivery, continuous deployment, and then continuous operation as well. So just to start to talk about continuous integration. Continuous integration is basically a practice of checking in your code to continuously uh, go ahead and push into your Git repository and then continuously verify it with each change with an automated build and test process. So over the last 10 years, developers have been following this or a very similar practice where, as you can see in the diagram itself, you go ahead and push your code into the central repository, you run some checks through automated tests, get a feedback, basically get results of your tests. If it's all good, you go ahead and move to the next phase. Otherwise, you just go ahead and fix the problems. The key goal for continuous integration is basically finding problems or finding bugs in common language as we use in development practice. This ends up in improving the software quality. And it actually goes ahead and reduces a lot of time taken to validate these problems when they go towards a more integrated setup in staging environment or even production. Moving on.
Like, oh, yeah, actually talking about continuous delivery, I was actually just going to make a point of it. I'll hold my question to you afterwards.
All right, cool. So now we talk about continuous delivery. It basically is an extension, or in other words, it expands upon continuous integration. So continuous delivery is a software development practice where code changes are automatically built, tested, and prepared for a release to the production. In simpler words, we create a package, a deployable package that can be pushed into production, and no one else can actually interfere into the code setup and all the configurations that we've made. It's usually tagged by a release number in our Git repository. If that's not happening, I would request you guys to do that in the practice, because it is really important when it comes down to finding a problem and tracking back and understanding which release was pushed at what time itself. Casey, do you want to ask that question?
So I was just going to say that in my old company, we had the CI/CD pipeline, and it was a real lifesaver when it came to support, because as the ticket was being resolved and that code was checked in, we could actually tell the customer, hey, that's like that issue has been fixed in the next 30 minutes as it went out to production. So it really helps enable that user satisfaction we found.
Yes, 100%. One of the main reasons why we should go ahead and use a CI/CD setup for application deployment itself. It gives you a very good way of tracking things, and also a seamless way to push things and your code into production itself. Very important. All right. So a lot of times we do confuse between these two, continuous delivery and continuous deployment. The reason for the confusion is quite valid because they're very similar to each other. But as you can see from the diagram itself, the main difference between the two is basically a human intervention that happens with continuous delivery. So the package that I was talking about earlier that is ready to be deployed to production, what happens is a lot of companies, including enterprise companies as well, they go ahead and want to make sure that the deployment happens at a particular time when everyone is good and happy with the results of the tests, and they are not 100% ready for deploying the changes right away automatically through the pipeline into production without any confirmation from a release manager or the team itself. And that's what continuous delivery is. It's like a precursor to continuous deployment. So after we have achieved a high level of confidence within our pipeline for that application itself, we move towards continuous deployment, where if any code is actually pushed into a main branch, it will go ahead and go through all the different feature environments or development environment, staging environment. We are ready with automated tests and the results. They are verified automatically as well. And once they are done, automatically everything gets pushed into production without any human intervention. It's like a North Star, to be honest. For deployment purposes itself, we do have another phase, which is called continuous operations, or achieving that is actually also called no ops, basically no operation intervention at all during the deployment, and also monitoring and recovery of any issues as well. But that's those are very few companies that have been able to achieve it. Everyone is striving for it, for sure.
And I've also seen hybrids where they'll have that continuous deployment for like support type roles and also for minor features. But for any big release, they go through like that gatekeeping process.
For sure, yes. So for big deployments, big upgrades and updates, a lot of companies use continuous delivery. And then for, as you said, minor feature changes, if there's a small bug that needs to be fixed, they can actually utilize continuous deployment. And that's a very good way to start with continuous deployment as well. It's just to gain confidence on those low-hanging fruits as well. Awesome. All right. So moving on to the next bit, which is another topic that we should discuss before talking about GitOps, that is infrastructure as code. So what is IAC? It's basically writing code to create, configure, and deploy infrastructure components. Infrastructure actually includes networking, compute, databases, security, and management tools as well. So why do we need infrastructure as code? So if you think about it, it actually makes infrastructure changes repeatable and predictable, which is very desirable in the market since the last decade, and it's still going on as well. I have so many customers who have to basically grow into different regions now, deploy their environments from Australia to go ahead and deploy them into newer AWS regions like Ireland, or if they want to expand their business to US. And they cannot use the Australia region for a lot of compliance reasons and latency issues and so on. So they have to deploy the whole set of infrastructure onto different regions as well. And this is where infrastructure as code comes very handy. You go ahead and just use the templates and the code that you already have. And instead of taking months to deploy into a new region, you go ahead and deploy that within weeks and even days for some very efficient setups as well. So,
and the hidden benefit as well, which I think a lot of people gloss over, is that it's also a very effective DR strategy.
Yes. Yes.
So as long as you have that backup process there, like if something happens to that whole entire environment, you can just move to another region, stand it up, change your DNS, and you're good as gold.
That's correct. That is my next point itself, DR.
Sorry, I'm jumping ahead.
No, it's actually, it's always good for a conversation. It actually shows how like-minded we are in terms of the problems that we are facing on a day-to-day basis as well. So for sure, DR is one of the other biggest reasons why we need infrastructure as code. It helps you gain confidence in your product and infrastructure as well. A lot of times we find it hard to explain to the business leadership teams as well how we can actually just recover very quickly when it comes to DR. And this is one way to actually go ahead and explain and tell them that we are ready for any kind of disaster recovery plans. Awesome. All right. So moving on to the next bit. When we talk about GitOps, I just want to first talk about how teams are working nowadays. So in regards to the ownership of infrastructure itself, everything is not relying on ops team anymore. It's basically kind of a gray line, and it's very soon, or it's already mixing into dev work as well. And a lot of dev work is mixing into ops work, which means you actually go ahead and own what you deploy. This started off a lot during the serverless usage as well. A lot of dev teams were able to understand how Lambdas work, and then in order to deploy serverless setup, they go ahead and have to understand Lambda functions, how they're connected to API gateways, and everything else. And in one of my previous companies, I was leading the DevOps function, and they used to come to us for various permissions. They wanted us to click on the release pipelines to deploy things, and they wanted to do that more seamlessly. What we told them was, we provide you infrastructure as code templates. We'll do that, but then you go ahead and own the product that you deploy and handle it. So all the release processes, deployments, testing, everything, you can go ahead and own them. And that's when they started getting more hands-on with infrastructure. And basically what happens is we merge together. It becomes a common goal to handle and own infrastructure that is basically attached or that hosts your application code as well.
Sorry to jump in here. Crypto Shepherd just said something about increase my volume. So I have increased my volume. So hopefully that's good now.
Okay.
I had to decrease it just to make sure people couldn't hear me breathing, which probably would be very distracting. He also said something about, I say you are bunting on the volume. Okay. Sweet. I thought that was the baseball a joke at first, but no, apparently.
All right.
I just can't read.
Just to make sure everything is fine from my end, is it? Or...
Yeah. Your volume is good. It's just that I'm playing around with my volume at the moment.
Well, yeah. You have to adapt to having the privilege of sitting in a very new setup for a studio.
I love it. I appreciate people, calling it out, because that's the only way we can improve, right?
Yes, 100%. And as I was saying earlier, the setup looks amazing. I just love the color of the wall at the back as well.
The only downside is that it highlights my kid. So now made me very self-conscious. Without all the extra lighting, it normally, it's a lot harder to tell.
That's the thing with working from home, right? So I set it up perfectly up till my upper torso and chest, so that I'm not conscious enough for the bottom bit at all. Awesome.
Anyway,
we
sorry
digress.
for the distraction.
Yeah, all good. No worries at all. Cool. So let's all move on to the next bit, which is basically when these responsibilities merge between dev and ops. What are the common problems when we have to, or we all have to manage infrastructure at scale? So it actually comes down to the infrastructure as code tools that we use. And now at this stage, when we are comfortable with them, the devs are comfortable with them, we want it to be easier to create what we need in the way we manage it in terms of consistency, automation, and versioning as well. So just learning infrastructure as code and deploying one set of environments, using it is not good enough anymore. We need to basically go ahead and make sure things are right in terms of consistency, as I said, automation, and versioning. And that's what we'll cover in the next slide. The first problem is basically automation and how we have grown from basically a GitOps setup, from doing things manually, where it is basically easy to set up when we're working on POCs. There's no problem. It is error prone, but then, as I said, if it's a test or POC, why not? We don't have any issues having errors over there. But then we move towards scripted, but then we have issues on understanding how do I know if a resource is ready or not. How do I go ahead and undo something? And that's why we move towards something which is a resource provisioning engine setup, basically going towards declarative, immutable setup of infrastructure rather than doing in place things. For example, when it comes to deployments, earlier, a lot of times we recommended to just go ahead and use tools like Ansible or log into the EC2 server and then just place your code over there. But then how are you going to make sure that it is automated? Well, you can use Ansible. But then a lot of times the problem comes down to tracking what changes happen when. And then also between environments where we have production, which is strictly controlled by the security team and the DevOps team versus a development environment where everyone has access to it. Changes happen now and then, and it is really hard to make sure that the environments are consistent. And that's why we need a more declarative setup where we have immutable deployments across all environments itself. Talking about consistency, this has been a problem since ages, as we know, and that's why we use GitHub for the same reason for application, but now we need to use this for infrastructure as code as well. As you can see, as more developers work on infrastructure as code, it becomes really difficult to identify the intended state. And just to understand when problems will start occurring and how we can fix it, and which change is correct and which change is not as well. So it is really important to be consistent with our deployments as well. The next bit would be versioning. As I was talking about earlier, when we were talking about application deployment, it is really important for us to go ahead and mark or tag our releases just to understand what version has been deployed, what was the previous version. Providing a clear audit trail is really important. And the same actually stands for infrastructure as code as well. So infrastructure as code are basically stored outside of a repository, often ends up in an S3 bucket. And then as changes are made to infrastructure as code files, it actually goes ahead and causes a difficulty for us to know who is making the changes and when they basically happened as well. So if a vulnerability is introduced to a file and that isn't hosted in a version control, it's basically impossible to roll back to a previous version itself. So that's why versioning is very, very important. Cool. So finally, we come forward and talk about GitOps. After talking about all these prerequisite topics, it is basically a single source of truth setup, easy to do rollbacks, and then perform automated testing. Let me go ahead and talk about that part. So this slide just talks about the 3 pointers that I made. And then we come towards what exactly is GitOps. So GitOps is an operational framework that takes DevOps best practices used for application development, such as version control, collaboration, compliance, and CI/CD, and apply them to infrastructure automation itself. And then the reason why I covered the previous topics was because GitOps basically requires 3 core components. The first one is infrastructure as code. So GitOps basically uses Git repositories as a single source of truth for infrastructure definitions, and that is provided by IAC. Second important part is merge requests. So GitOps uses merge requests, popularly known as pull requests, as the change mechanism for all infrastructure updates. And the last bit that we covered quite significantly is CI/CD. So GitOps basically automates infrastructure updates using Git workflow with CI/CD. So basically, when new code is merged, the CI/CD pipeline enacts and changes happen in the environment. Basically, any configuration drift, such as manual changes or errors, will be overwritten by GitOps automation. So the environment actually converges on the desired state defined in your Git repository itself. This basically happens using configuration files. They're usually YAML files when it comes to Kubernetes, and it can be tracked down to tools like Terraform as well, where you set a particular state. We have a state file which actually defines the current or desired state, and then you can actually track drift as well. Similarly, done through CloudFormation as well. As we all know, through the AWS console on CloudFormation, you can actually go ahead and detect drifts as well.
I'm assuming this integrates just as nicely with Terraform.
Yes, so it does. And the thing about GitOps is that it's very flexible. As long as you have a system that actually goes ahead and polls from your Git repository, it is very easy to integrate things as well. In the example that we are looking at today, you can see how we've incorporated this flow for Kubernetes. So we perform the basic continuous integration and do various tests, builds, and push them into Git repository. Also make sure that we have the builds for our container images pushed into the right registry for containers as well. Once that is done, Git basically is being polled by any tool that we're using for GitOps for going ahead and deploying the state that we have defined, observing it on an ongoing basis. That's why we are polling, and then also creating observability setup where we understand what is the live state of our cluster, for example. And then we can integrate this with various operation tools as well in the future. Cool. Let's go ahead and talk a little bit about principles of GitOps. They're basically very straightforward and simple. So a system managed by GitOps must have its state expressed declaratively. Basically, what I was talking about was having a desired state, understanding the whole complete setup of the deployment of the application is very important, rather than just the difference that has to be deployed as well. And this is where it can be a bit different than other pipelines where we just use Terraform or any other tool just to deploy using the differentiation, rather than the whole state of setup and then going ahead and remediating it as soon as we find a change that happens when it's out of sync. The next one would be desired state. Is basically stored in a way that enforces immutability and versioning. Again, immutability, just in simpler terms, when we talk about virtual machines or EC2, if you want to deploy a new set of code into an EC2, we do not do that by logging in and changing the files. We just go ahead and create a whole new package of the image and then replace the EC2 instances is how I can best explain immutability as well, just to keep it into simpler terms. And then basically know how to retain the basic version history of these deployments as well. Otherwise, we can talk about software agents that automatically pull the desired state declarations from the source. So basically talking about polling all the live and desired state forms from the Git repository where we've declared it, and then making sure it's the same across the board to what we have actually deployed. And then lastly, software agents continuously observe actual system state and attempt to apply the desired state. So this is where we talk about remediation. If something is out of sync, it can automatically do so. Just to confirm, we can stop that. So if you want to actually not remediate things when you're testing things, you want to make changes and then see what those changes are, you can stop tools like Argo CD from syncing automatically. You can do that manually as well. Cool. So this is basically a simple comparison between traditional CD systems and GitOps-based systems. As you know, we go ahead and trigger pipelines to go and deploy things. Over here, it will continuously poll for changes that are happening. So whatever you deploy to your Git repository, it will sense it and then go ahead and deploy the same for you quickly. Deploying the basically difference rather than the entire state of declared setup and deployment. So basically, GitOps works better in that way rather than just finding the diff for the next one, because when you go ahead, it might not be able to check for any changes that have been made manually or made through errors as well. And we'll see that in the demo very shortly as well. And so on. So they are basically pretty straightforward in terms of fixing any kind of drift that is happening. Otherwise, with traditional CD systems, you have to do that yourself a lot of times and then push the changes and fix things by yourself as well. Cool. As I was saying, a lot of companies are going ahead and utilizing GitOps, and basically the end result is more consistent version and automated way of provisioning. So some big names would be Deloitte, Expedia, and Coinbase, who have incorporated GitOps and have actually publicly spoken about the great benefits that they've received in terms of consistency and automation. Cool. And I think we can quickly introduce Argo CD. So Argo CD, as you can see on the screen, looks like this. For a change, a GitOps tool for EKS that is UI-based as well. So it is not a tool that only provides UI. I'm pretty sure a lot of devs and DevOps people might get startled by only looking at UI and making changes over there. They'll just mention it to be kind of a ClickOps setup as well. And for people who completely hate UI setups for deployments, Argo CD does provide something called Argo CD Core, which does not utilize UI part. It just uses, as the name suggests, the core components of deploying it via either CLI or APIs itself as well. So what is Argo CD? Quickly, Argo CD is basically an open source declarative GitOps continuous delivery tool for Kubernetes. It basically follows the GitOps patterns of using Git repositories as the source of truth, defining the desired application state. And as I was talking about earlier, it is basically offering 3 ways to manage the application state. The first one would be CLI. So in real world, what happens is you do not use the UI for deployments and syncing at all. When you're using pipelines, creating CI/CD, you go ahead and use CLI options or API versions, or even one of the ways to utilize this would be Kubernetes manifests and Helm charts as well. And then the user interface. So there's a very interesting aspect that I understand about humans and myself as well. So just digressing a little bit. I was playing a game yesterday. It was basically with some team members. It was basically a timing game. We were given questions. You need to name 3 things, and then you get like 10 seconds, and there's a timer that runs. So I was asked to name 3 things that have an annoying or irritating sound. So I just had 10 seconds. So I first said the timer sounds annoying. There was music running in the background. And I said, that music sounds annoying as well. And I just had like a split second. So I could not imagine what I could say. So the person asking me the question, I said to him, your sound is annoying. I never meant.
Way to make friends.
Yes, 100%. So everyone laughed. Thankfully, everyone knows me, so they understand it was not meant to insult anyone. But and it's a game, right? But I'm talking about when in pressure, when things go bad, when there's a time constraint, we sometimes do not think straight. We have issues going and tracking things. And this is when something like Argo CD and UI will come very handy. So when things go bad, when your application is out of sync, you want to understand what's happening between various components of the EKS cluster or the components of the deployment within Kubernetes that you've pushed through. This is where you can track it down and remediate it very quickly, rather than people shouting at you and then trying to go to CLI and finding it difficult to track it down within the right time required. And that's why people have also liked tools like K9s. It gives you a tabular form of understanding how the cluster is working, and you can make changes over there as well. Lastly, the part that we talk about use cases, again, pretty similar: automated deployments, observability, and then operation. So it covers it all. And how it works. So we can quickly cover that part as well. So basically, Argo CD controller in Kubernetes cluster continuously monitors the state of your cluster and compares it with the desired state defined in the Git that you've set up. If the clusters basically does not have the state and it does not match the desired state, Argo CD reports the deviation and provides the visualization to help developers manually or automatically sync the cluster state with the desired state itself. And as you can see, we've incorporated different tools as well. You can see other tools that you can use for GitOps and basically make these changes as well. All right. And we can move towards the demo now. I hope we have enough time for that.
We got 20 minutes, so there's plenty of time.
Wow. Yeah, perfect. Cool. So let me go ahead and share my other screen quickly.
And while you do that,
Yep.
Kaptesh Shiba has been talking about he's going through the journey of working front end and moving to the back end, getting up that full stack web development, which, yeah, it's a long process. Like, I have gotten rusty with my front end. So I'm actually doing some internal work with modern front ends, like Vue 3 specifically. And holy heck, there's a lot to relearn. Like, even doing simple stuff, I'm like, I know what to do. How do I do it?
It's always a struggle to go back to things, for sure. And it's just like that learning curve. Let me quickly see if I can share the right screen. Let's see.
Yeah, it very much is a never-ending process of learning. Like, you always have to learn something. Like, the realm of IT is so vast.
Oh, yes.
Which is why I also lean on you for everything EKS, because I know nothing about it.
Yes. For me, what I define it as is a continuous process of forgetting. We go ahead and remember something, but we end up forgetting it. So we just have to go back every time and relearn it. So for me, it's like a continuous process of forgetting everything all the time. Awesome. So Argo CD live in action. I'll just go back onto the main page. So this is already set up. So what I'll do is I'll reset it, everything for you guys to see how it works. It starts off by creating a basic app. So you can have your production app, development app, and staging app separately. Or you can actually have these as separate environments as well, and then deploy a combination of apps within Argo CD under a single setup. It's also called app of apps. It's another thing. If you guys are interested, you can go ahead and check it out as well. But today we'll just consider one basic UI app deployment itself. Cool. So what I've done is I've set up a Cloud9 setup that connects with my Kubernetes cluster. And I'm going to use the CLI to go ahead and make changes, push to the Git repository, and so on as well. So what I'll do quickly is show you how we can go ahead and create an app and then deploy things. So the first thing that I'll do is I'll go ahead and delete this. And I'm going to basically rely on the presentation and demo gods to be with me, and I hope we can deploy this in a proper way quickly, because a lot of times, even if you've tested this out like 100 times, when you present it, it goes bad. So let's try it out. So the first thing that I
was going to say, we've only had one demo on this show that has ever failed, so...
all right. Okay, cool.
No pressure.
No, none taken. All right. So what I'm going to do is I'm going to first of all clear things up. So I did delete the app first. I want to just go ahead and clear the folder where I had.
Can you increase the font size of your?
Oh yeah. Let me see if I can do that quickly.
Just like 130 or something.
Is that good?
Yep, that should be better.
Awesome. All right. So just clearing that up and just going ahead and pushing through a few Git commands so that we can start fresh. So this will just clean everything, and I can go back to the initial setup. So as I said, I'll be using the CLI. This command is basically to, as you can see, Argo CD app and create apps. So this is what we're creating, something known as apps. And then it will go ahead and but we have to declare the repository that we want to add. So this has already been added to Argo CD. And we can actually, if possible, share a very nice workshop link for you guys to get hands-on on as well, if required, for this bit. So I'm going to just go through this part. Let's see if... All right. Yep. So it says the app should be created. Let me go back. It was not, but now as you can see, it has popped up, and then it's basically having nothing at the moment. All right, going back, we'll go ahead and copy a UI microservice YAML files into our Git repository folder quickly. So let me do that very quick. So basic copy command, and then because the code has been copied across, we just push using basic Git commands where I'm just adding it, committing with the same message that I did previously. Please do not do that. Always use fresh comments. This is just for demo purpose. All right. So the next bit would be just to go ahead and put a sync command from here. You can do the same on the UI, but as I said, you can actually go ahead and set it up as an automatic sync as well, where it polls regularly. So as you can see, it's showing me the app health, sync status, and last synced. But if I go ahead and refresh it, we see all these various components of the deployment that we want to make. And it's really handy because you can actually see what each kind is. So the first one is config map. If I go back, you can see service. You can see what is the service account, and then obviously the deployment. And that's just to understand what each is. You can click on each of them and then actually look at the live manifest, the desired manifest, which is basically the manifest or the state that you've defined in your Git repository. And then if there's any difference, you will be able to see the difference over here, which there is not right now, but we'll play around with this one and then show you how it works as well. And if I just scroll on the right side, you'll actually see the pod that has been deployed. As you can see, it's a replica set, and we will be able to see how many replicas are there. So one at the moment only. So this is how you can actually go ahead and track things. And let me see if I go ahead and look at this. I can enable auto sync as well. So rather than me going ahead and giving the sync command or clicking sync on the UI, it will just do that on a regular basis. So the best part, let's try to break this or put it out of sync and see what happens. Again, testing my luck here. So hopefully it will work. So basically going towards the live manifest, which is what is happening right now. One of the great things about Argo CD is you can change it here itself. So it will basically perform kubectl commands to make the changes for you. Test it out or make changes anyways and see how your cluster or app reacts to it. So what I'm going to do is I'm going to set it to 0. Done. And as you can see right away, we can see it's out of sync. We can also see what the last status was, which means you can understand the history of the performance of syncs on your cluster as well. And we can see that we do not see any pod deployed, which means the replica set is set to 0. The thing that we were talking about earlier, let me quickly go towards that. So as you can see right away, we can see there's a diff generated as well. This basically talks about the replica set being out of sync, where we've actually had it as 1 earlier, and now it's basically 0. So how to fix it? Either if you've already set up auto sync, you can just wait and it'll fix it by itself, but we've not done that. So let me just go ahead and click on sync and synchronize. And there you go. It goes back. It knows that your Git state is basically having 1 replica. So it will go ahead and deploy it to the desired state rather than what it is right now. So the same will happen if you go ahead onto the kubectl commands or anywhere else and delete a pod. It will go ahead and detect the state and then apply it in the right way. And this makes it very easy to automatically remediate to the desired state that we want it to be as well. Cool. What we're going to do is demonstrate GitOps as well. This was how it breaks and fixes it. But then what happens when we change things on the Git repository side as well. So let me try one quick thing. Let me see if we can enable autosync. And as you can see, you get other options as well. So self-heal and prone resources as well is an option which you can disable. Awesome. Cool. So what will happen next is I will make a change in the deployment YAML from here to go ahead and add the replicas to be 3 rather than what we have right now, which is 1. Once I do that, I will go ahead and perform these basic git commands, which is adding this change, committing it with a new commit message, which is good. And let me copy the right one. And then pushing it across. All right. So ideally, what we should see is that without me clicking on sync or pushing the sync command through CLI, it should come up and update by itself just by pushing the changes into our Git repository. So let's see if that happens.
While we wait for that, if
Yep.
anyone has any questions, feel free to chuck them into the chat. For the time being, let's do a couple of like get to know each questions while we're waiting. What was the first programming language that you learned?
First programming language. Wow. All right. What was that? The first one was Java. That was back in uni. But then since then, after completing my uni project, I did not touch Java after that, to be honest. On a day-to-day basis, at the start of my career, I was more into Python just to automate everything as much as possible, from the smallest tasks to infrastructure as code, and then deploying things, and also using it for the data platforms that I worked at. So, yep.
Yeah, Python's very common in the data world, so
Yeah.
not
Yep, for
surprised
sure.
that's what you were pretty much mainly using.
Yes. And then at the start of my career, I was basically a systems engineer. And like we were asked to go ahead and do things manually, so ClickOps based. But I did not like that. And that's when I fell in love with Bodo 3, where you can use Python to just call the APIs and then automate everything. So that's why Python was used a lot by me at that time. What about you? I'm pretty sure people would have asked you that already on the show.
I don't think I've talked about it for a while, but my first programming language was back at college when I learned VB. So
Wow. Okay.
A very much dead language. Well, it's still around, but if you're using VB still, you got bigger problems in my opinion. And then same with you, Java at university. But when I went out from university, I worked in Microsoft Partner for a long time. So C# is really my default language most of the time.
Yeah.
But I'm also quite strong in Python because I've been doing a lot of data stuff for the last 6 or so years.
Yep.
So TypeScript as well, or JavaScript I'm across, but I'm more someone that you would deploy into something if you want to test whether or not I can break something.
Yes, I think people who have gone ahead and used or basically learned C#, other languages tend to be quite easy for them to incorporate as well.
And expect NZ directly after we finish the stream, this will go into the VOD library. So if you just go twitch.tv/AWS/videos, as soon as we go offline, it will just appear in that library and you can just click and watch it from the very beginning.
Awesome. Good timing. As you can see, I did not click anything, I promise. It actually went ahead and synchronized on its own, and now we can see 3 pods up and running over here. So it works. I'm happy. And it's a very powerful and useful and simple tool to use as well. And just generally, GitOps is something that we should all incorporate in our daily practice.
Yeah, and also they just Curtis Shepard just brought up C++. That's a whole kettle of fish. You don't really want to dab on that dark art unless you have to. It's quite a lot of fun, especially when you accidentally create a memory leak and then you spend like 2 weeks trying to fix it.
It's yeah. Supporting C++ is it's and I would salute to people who actually do that. That's an amazing thing.
It's gotten a lot better. I think C++, I think it's up to like some ungodly number. I can't remember off the top of my head. But it's gotten a lot better in the tooling and whatnot. I'd still much rather use C++ and Objective-C. So, but that's we've gone vastly off topic.
Yes. But talking about that topic, I really like the fact that people are moving towards .NET Core from .NET Framework. I think that is changing the game for everyone and making things very easy. Just talking about like a regular topic that people talk about as well when it comes to containers, especially.
For like workloads, especially if you're going to be using containerization, like Windows containerization is pretty rubbish. You don't really want to use it unless you want to burn a whole bunch of money. Again, that's just my opinion. And .NET, because .NET Core is now just called .NET because that's how things work. That is really enabling like a lot of those historical window workloads relatively frictionless. Like there's always going to be friction when you move between like certain libraries and stuff like that. It's a lot nicer migration path to go from .NET Framework to .NET.
Yes.
And then you can containerize it, and then like you win on both fronts.
That's correct. It's like a huge bump up in terms of advancement when you go away from .NET Framework, and we do have services that help you with that as well. So app to containerize.
We won't go into that.
Yep. I'll keep quiet. I won't go.
It's about our scope, and we're running up to time.
That's right.
Is there anything else you want to cover off in the demo?
Nah. So this was it. I think I'm happy with the demo. As you can see, it's syncing well with GitOps, and that's what the desired state was. So simple it is.
Awesome. Well, I'll leave it there, like unless there's any last minute questions that pop through. Thank you, Navya, for coming onto the stream and proving that the Anzac spirit is well and strong, and sharing expertise with us all.
Awesome. Appreciate it. Thank you a lot.
And thank you, Crypto Shepherd, for being so engaged. It's been awesome. And with that, I will say Matiwa, and everyone enjoy the rest of the week and the weekend.
Thank you, guys. Thank you, Casey. See ya.